Okay, continuing on with matrices and solving systems of equations. Now, we want to find a solution to this system of equation using most famously known as Gaussian elimination or Gaussian Jordan elimination. Some books refer to this as using matrices or row operations, depending which book you use. Now, what we're going to use a combination of those. Our goal is to write an augmented matrix in an upper triangular form. The idea is to make sure that this is a 0, this is a 0, and this is a 0. And once we do that, as we saw in the previous lecture, we use backward substitution to figure out how this works. So once we get it this way, we say, well, let's say that's f times z equal I, solve for z, and so on and so forth. That's the idea. So the idea, first step, is to write this as an augmented matrix. So this looks like this. Again, the book doesn't really put that line there. I'm going to put that line there. That is a 1, 2, 1, negative 3, 1, 2, 1, negative 2, 4, 3, 5, and a negative 2. So, my goal is to get there. Now, Gaussian elimination is really making those entries a 1 each. We could do that at the end. Like I said, we're going to use a combination. This is called an upper triangular matrix. That's what we're going to go for. There are many ways you could do this. We're going to aim for this. So our goal is to make this a 0, this a 0, and then after that, this is a 0. The order is very important. Now, we are going to learn about Gaussian Jordan elimination when we do inverses, but for now, let's do the least amount of work and get to the answer. How do I make this a 0? I could use any combination I know, and from the previous example, I would set row 2 to equal if I multiply row 1 by a negative 2 and add it to row 2. Oops. Shouldn't that do the trick? At the same time, so that I could save time, I could also make that a 0. And how is that? I could say, let row 3 equal, how do I make that a 0? If I multiply row 1 by a negative 1 and add it to row 3. So this tells me what I'm going to do next. And when I'm grading your work, it tells me what you're doing because it's very hard to follow. Make sure that you list what you're doing. So this is the purple part. Multiply row 1 by a negative 2. That would become a negative 2, a 6, a negative 2, and a negative 6. And if I add that to row 2 is 2, 1, negative 2, and a 5. If I add those, that will be a 0, a 7, a negative 4, and a negative 1. Now notice, row 2 and 3 are changing, but row 1 is not. So row 1 I could just copy. Now the next step is for me to take maybe I should put those here. The next step is for me to take, just to separate between those, let's go with the bluish. Take negative row 1. If I take negative row 1, that's negative 1, a 3, a 1, and a negative 3. Add it to row 3. Now I suggest you do something like this because the chances of making a mistake is very high. And you really don't want to mess this up. And there it is. Now what? Now I have one more step and I use backward substitution. I could divide row 3 by 5 and put it back in, but since I'm doing this in the least amount of steps, I'm not going to worry about that. Here's the catch. To maintain those two as zeros, in the next round, I shouldn't use row 1 at all. So I want a 0 right there. I'm going to let row 3 equal. How do I get a 0 using only those two. If I multiply row 2 by 5, row 3 by 7, and make one of them negative, it doesn't matter which one, that'll do the trick. So pretty much for a 3 by 3, 3 steps and I'm done every time. In 3 steps, I should start using backward substitution and get it to an answer. So the first row, unused, unchanged. I'm using row 2, but the only thing that's going to change is row 3. And if I multiply, what did we use? Green. If I multiply row 2 by 5, that is 0, 35, negative 20, and negative 5. If I multiply row 3 by a negative 7, 0, negative 35, negative 35, and 35. And if I add those, I'll get a 0, 0, negative 55, and a 30. The numbers are not going to work out nice because I made those up, but that's okay. We could handle a bit of fractions. And now that I have this matching the upper triangular, what we'll do, we'll say, all right, now that I know this, let's solve negative 55z equal 30. So z equals 30 divided by 55. Divide by 5, that's a 6. Divide by 5, that's an 11. Again, normally the numbers work out nicer, but since I'm making this up, that's not going to happen. But that's okay. We need as much practice with fractions as we can anyways. I go up one level and I say, if you take 7y, if I multiply this by a negative 4, that's 24 over 11 equal negative 1. Clear the fractions. Again, not a pleasant. Add that to both sides. 77y equals negative 35. So I'm getting y to equal negative 35 over 77. And now if I go for the first equation, to figure out what x is, I will say x minus 3 times that, that's plus 315, 105, plus z minus 6 over 11, this is over 77, equals a 3. Oh boy, this is a big mess, a lot messier than I thought, but it's all good. We have 77x plus 105 minus 7 times, that's 42, and 77 times, so I have x plus 105 over 77 minus 6 over 11 equal f3. Clear the fractions. I have 77x plus 105 minus 7 times, yeah, that's 42, and 77 times 3. 21, 21, 20, 23, 231. Again, a bit messy, but your problems on the test should work out nicer than this. Because I'll make sure that the numbers are nicer, but you know. So what is that? A 3, 63, 77x equals, subtracts 3 minus, that's an 8, 6, 6 minus 12 is a 6, 168. So I get x to be 168 over 77. I'm not going to even check if this reduces or not. If I made a mistake on the algebra, you do get the idea. Now the chances of you making a mistake will be very high unless you work those out the way I did. So I'm mainly looking for the answer, of course, but are your steps geared toward making this a triangular matrix? That's the first thing I look for. Alright, so again, the numbers turned out to be messier because I made this up. I apologize, but that's what it takes. That's not a problem. We could do that. How about this problem? Well, same deal. if I take this problem and I write it in augmented matrix form, I'm looking at a 2, 1, 1, negative 3, 1, 2, 1, negative 2, 3, and a negative 9, 0, negative 5. My first goal is to make that a 0 and that a 0. So let me do that in one step. That is, let me take, and make sure you write down what you're doing. I'm gonna let row 2 equal, well, if I multiply row 2 by a 2 and add it to row 1 and make one of those negative, that will work. Negative 2 row 2, or 2 row 2, that's 2, yeah, that'll work, that's perfect. So that would be how I will make that a 0. And again, I am stating where I'm putting the result. So if I do that first, remember, I only need 2 steps for a 3 by 3, 3 steps for a 4 by 4. So this is one way to organize how to do systems of equations. So let's do that. If I multiply row 2 by a 2, this by a 2, that's a 2, 2, negative 4, and a 0. Row 1 is actually 2, negative 3, 1, and negative 9. If I add those, minus row 1. If I add those, that's a 0, that's a 5, negative 5, and a 9. Okay, now, if I want to make that a 0, can't I say let row 3 equal, and I could take negative row 2 plus row 3, just multiply this by a negative 1, that will be a negative 1, positive 2, and a 0, and row 3 is 1, 2, 3, and a negative 5, and if I add those, that's a 0, 1, 5, and negative 5. 0, 1, 5, and negative 5. If I'm not mistaken, yep, that's what it is. Okay, now what? Now the next step, I want to make that a 0, but again, I have to use only those 2 rows. So here, row 3 is going to equal, if I take 5 times row 3, add it to row 2, but make one of those negative, it doesn't matter which one, that should do the trick. So here, I'm looking at row 1, I'm not using nor changing, but let's see. Row 2, I am using, but I'm not changing. The only thing that's changing is row 3. So if I take row 3 multiplied by 5, that is a 0, 5, 25, negative 25. And if I take negative row 2, that's 0, negative 5, a 5, and a negative 9. If I add those, now I could do, well, it doesn't matter. And if I get this far, then hey, that is the triangular that we're talking about. I'm in a very good shape. Now what? I take the last equation and say 30z equal 34. So z equal 34 divided by 30. Again, the numbers are not going to work out nicely, but we need to practice as much fractions as possible. I know you disagree, but that's how it's going to work. How about this problem? This is 5y minus 5 times z, but I know z is 17 over 15 equal 9. So 5y minus, this divides that 3 times, 17 over 3 equal a negative 9. I clear the fractions by finding the LCD. That's missing a 3, 15y minus 17 equal negative 27. So 15y equals 10, negative 10. And y would equal negative 10 divided by 15, which is negative 2/3. Good. I got 2 of those. I go back to the first equation. The first equation reads 2x minus 3y plus z equal a negative 9. And here I will say, those cancel out. I'm looking at 2x minus plus 2 plus 17 over 15 equal negative 9. Clear the fractions. 30x plus 30 plus 17 equal, if I take 15 times 9, 45, 135. So this is 30x plus 47 equal negative 135. 30x equal a negative 12, 8, 182. So x would be negative 182 divided by 30. I'm going to divide by 2. That's a 15. 18 divided by 2 is 91. So my solution to this problem is negative 91 over 15, negative 2/3, and 17/50. Oops. Okay, nothing's working out right today. Here we go. Now, gonna stop this video here. I'll complete this in the next video.